Part of the reason I'm talking about this is that most of these questions are going to incorporate something called function notation. And function notation looks like this. You guys remember seeing that type of symbolism? Okay, this does not mean f times x. Okay, this is what function notation is designated as. And the way that it's spoken is it will be f of x. Okay, f of x is simply replacing the y in an equation. So if you have an equation that says f of x is equal to 3x squared minus 2x plus 1, let's say. Okay, it just replaces the y and it tells you it's a function. Being a function adds like a little bit more to what you're dealing with because a function has some specific properties that's not shared by all equations. And so if something is a function, you might see f of x, g of x, h of x. They do tend to be in the middle of the alphabet, the letters that go in front. But again, this is not f times x. Okay, this is f of x. And what function notation tends to be used for, especially in the context of the SAT, okay, or standardized testing in general, is it's used where the value that's inside the parentheses is a placeholder. Okay, and so when you look at this, if I have f of some number here, and so if I have f of 2, what that means is I'm going to take the original equation, 3x squared minus 2x plus 2, and I'm going to write it. Notice kind of when you see me write these out, everywhere there's an x in the original equation, so right here and right here, I'm going to use that as a placeholder. That's just a placeholder for whatever value is written inside my parentheses here. So if I take my f of x function and I evaluate it for f of 2, that means that I'm going to place 2 everywhere in my function wherever there used to be an x. So I'm going to place a 2 here for this x, and I'm going to place a 2 here for this x. And so that's what function notation represents. And so if you evaluated this, you would get 3 times 2 squared, which is 4, minus 2 times 2, which is 4, plus 1. So you would get 12 minus 4 plus 1, which is 8 plus 1, or 9. So what that means is f of 2 is equal to 9. I'm going to write it here on the different line here. So f of 2 is equal to 9. Now, when you're entering these on the MyOpenMath, you can enter as an equation if it allows it. Okay, but for the most part, your answer would just be f of 2 is equal to 9. Now, here's how that sort of relates to points on a graph. Okay, notice that the way that this is saying, if you just look at the function notation, y is equivalent to f of x. Okay, so at the word or the phrasing f of x, the function notation simply replaces the y. Okay, and so what that means, I'm actually I'm going to reorder this. I'm going to write f of x on this side. So f of x is equivalent to y, okay, and it replaces y in an equation. So what that means is when you look at this relationship right here, you see that when x is 2, the corresponding y is what? What did we evaluate? We got 9. Okay? And so when you see a function notation like this, it actually can be translated into the point xy on a coordinate plane. So that means that the solution for this problem right here would be 2, 9. Okay, so f of x equals y can be written, if you know that an ordered pair of 2, 9 exists in the function, you can rewrite it as f of 2 equals 9. Okay, so this is sort of the general summary of the types of questions that you will likely see when you are working on a standardized test question involving functions. Okay, so let's look at some examples of this. Okay, so let's take this first problem right here. Okay, I want you to see if you can evaluate f of negative 4 given the function that f of x is equal to negative 10x plus 7. See if you can evaluate that really quickly. Okay, so this means that you're going to take your original function, negative 10 times some placeholder plus 7. And in the parentheses, in that placeholder, you're going to put what number? Negative 4. And so what do you get when you evaluate this? 40 plus 7, which is 47. Perfect. Now, you could also just enter your whole calculation, right? We could have entered this as our answer too. Okay, or you can enter the calculated value. But that is how you would evaluate that function. Okay, let's see if we can extend it to something I haven't specifically talked about. But would you be able to interpret the information that I provided up in that box to answer this next question? What would f of 8 equal based on the table of values that you see? So go ahead and write what you think the answer is there, please. So here, this is based on this relationship right here, right? It's saying that f of x, the input, has an output y. So this is saying if x has an input of 8, what's its output? And you see right here, when x is 8, the output is perfect. So that would be your solution. Now, you may also see this in a slightly different way, but also similar to what I just showed up in the notes for this last example. Try this last one in that column of questions. Can you identify what point would exist on the graph of this function based on the given function notation? That's based on that same set of notes right here, that the f of x equals y means that an input of x equals an output of y. So what would f of 5 equals 35? What order pair would be on the graph? An input of 5 with an output of, so 5, 35, which would be that first choice. Very good. All right, questions on those. Like those are some of the basic type of questions that you guys will see in a couple years. And possibly when you take the PSAT, if you guys are doing that this year. I'm not sure if you are. Okay, let's try this last one here. Okay, see if you can extend what we've been talking about and see what if you want to evaluate a function and all you're given is the graph. Now remember, the graph is the listing of all the corresponding input and outputs. So can you find what is f of minus 2 equal to based on what you see in that line? So once again, I haven't specifically talked about this, but the idea is the same. F of x equals y means the input of x gives you an output of y. And so what this is saying is the input of negative 2. So when x is negative 2, what's the corresponding y? And what'd you guys get for that? Perfect. So you look on the graph, right? When x is negative 2, go up on the graph and see what is the corresponding y value, and you see that it is 2. Well done. All right, questions on function notation? All right, so a portion of your questions from this assignment will be recognizing and interpreting function notation. The other questions are going to be from the following content area, and that is taking a linear function and interpreting what exactly it means. Okay, and so a linear function means you have an equation in this form, or a relationship in this form, where you have y equals mx plus b. So that's the equation form of this, where m is the slope and b is the y-intercept. So that's what we know of it as far as the equation goes. But let's interpret this. This one's going to ask you to take the given equation and then interpret what it means. Well, the b value can be written in front. A lot of times it's written in front, but the b value is your initial amount. Okay, it could also be thought of as the amount at time 0. So notice how I designated this. It's the amount at t equals 0. So the amount at time 0, does that make sense that that would be the initial amount? You start at time 0, so it's the amount that you start with in a linear function. And a lot of times, especially if things are being removed, so like if at the beginning of every month you have $100 in your wallet, and then you start spending money during the month, a lot of times that b value, that $100 will start at the beginning of an equation. The slope is the rate of change. And so if you have $100 and every day you remove $10 from that, that would be negative 10. That's your rate of change. It's minus $10 per day. Right? And so you might see something like if you have $100 and you're removing $10 each day, how many days will it take before you run out of money? That's kind of a modeling question that is similar to what you're going to see. All right, let's start with this one down here. All right, so based on the given equation that you see right there where you have a linear form, 33h to the power of 1 plus 102, see if you can interpret what's being asked in this question. So if you look at the equation that's used, you have your initial value, and then you have your rate, right? So you should be able to interpret that the total cost is going to be $33 per hour plus the initial cost of $102, right? So you start with a 102, and then it's billed hourly after that, okay? And so that's the relationship that's going to happen. So if one job is 5 hours longer than the other, how much more is that person going to pay? 5 times what? 33, the hourly wage, right? So that's interpreting that the 33 is that rate of change. So if you take 5 times 33, 5 times 30 is 150. 5 times 3 is 15, so 150 plus 15 gives you 165. All right. I'm going to talk you through this top example. Okay, so this is one of the questions where, remember, as you go through your assignments on these algebra questions, you don't need to do all of the questions. You just need to reach a minimum score, and you're done. So it's possible that this might be a question that you skip through, but I do want to talk through it because it's set up kind of like this, but it's a little bit more challenging than maybe what you would expect. Okay, so one of the strategies specifically to SAT when you're taking those is I would always encourage you to scan your answer choices before you even start looking at the problem. Okay, so if I look at these answer choices without reading the problem, I see that I'm going to create a linear equation here. And my options are what looks like a rate of change of 11 times n plus some differing y-intercept or initial value, or it's going to be 34n with a negative number to start with. And so that's what I see before I even read what the question is. And so this says for groups of 29 or more, a museum charges $23 per person for the first 29 people. Okay, so when you look at it that way, what you see is that 23 times 29 is the initial amount that's charged, right? So it's $23 for the first 29 people. And then after that, it's $11 per person. Now, when I set this up, would it make sense that that would be 11 times n plus 23 times 29? Tell me why this would not make sense. Let's say n was 29, or let's say n was 30. If there were 30 people here, it's $23 per person for the first 29. How many more people are there after the 29? Just one more, right? So that means that you're paying 23 times 29 plus 11 times just one more person beyond that 29. So how can I express that so it's not a 29, or it's not a 30 inside here, it would be a 1. I would take the number of people and subtract what from that? So the 1 is what we're left with. So if we had 30 people and we want to be left with just the one person, what am I subtracting? I have to subtract 29, right? So again, think about it. If there's 32 people, we pay $23 for the first 29. And if there were, what did I say, 32, how many people are we paying $11 for? 29 have already been paid for. That leaves 3 more, so 3 times 11. And the way that we get to that is we take 32 minus 29. So this is actually what the model gives us. So this little adjustment right here is the trick to this problem. Right, and so now if you distribute everything, you'll get what your answer is. So 11 times n minus here, when I calculate and get the 29 times n is a total of 319 plus 23 times 29 gives me a total of 667. And so when I calculate this whole thing, I get 11n plus, if I take 667 minus 319, I'm left with the 348. And so that's where my answer comes into play. Okay, the most commonly missed answer, the most common answer that you guys or students would choose is this one right here. 11n plus 667. That's just missing it and saying that it's just 11 times every one that's paid. Okay, so be really careful on something like this. On an SAT, this question would fall toward the end. Okay, the SAT tends to give you the easier questions first, and then it gets harder and harder as the questions move on. I assume they're going to keep that same pattern with the digital format. All right, let's look at the two questions here to the right. Are equations that have multiple variables in them. It's still a linear form, okay, but it has multiple variables. I want you just to read this first question and see if you can interpret what does the 5g plus 51r equals 330 represent. See if you can answer that question. Okay.
46.
There you go, well done. Okay, so this question looks a little trickier than it is. Okay, this one is just a matter of interpreting what it is what does that equation mean. So you have 5g plus 51r equals 330. And notice when you read about it, it says students can win colored tokens, that's what the G for green and R for red represent, that are worth a different number of points. So the number of points is their coefficients. Okay, so that means that every green ticket is worth 5 points, and every red ticket is worth 51 points, right? And then the total number for whatever student this is or whatever this models is 330. So the question is asking how many more points is a red token worth than a green token? So the red token is worth how many? 51. A green token was worth 5. And so that's all they're asking you to find. So 51 minus 5 leaves you with your answer, which is 46. Okay. All right. See if you can kind of apply a similar type of logic here to the next question, which also has the two unknowns in the equation. Okay, can you figure out what those represent in the context of the whole question? Right, so what does, and I'm just going to break it down into each individual part, and then we'll look at the whole thing. What does the x represent? It specifically tells you the x is the what? X is the number of small jars. What's y? Y is the number of large jars. So there's two parts of that. So what does the 2 in front of the x mean? That each of the small jars holds what? 2 cups. Perfect. And what does the coefficient, the multiplier in front of y mean? Each of the large cups holds 7 cups. And then the total number of cups is 57. So that's what our equation represents. Okay, so when we want to find what it's asking, what is 2x? So is 2x the number of small jars? No, that's just x, right? So we can eliminate that. X is the small jar, so we don't even have anything to do with the large cups or the large jars. So we can eliminate all of those. By process of elimination, we're down to one answer. This is the only answer it could possibly be. And is it confirmed by what we are expecting? The total number of cups of broth in the small jars? Yeah, because it's x small jars at 2 cups per, so 2 times x is going to give you the total number. Okay? And so that's just a matter of interpreting the information that's given, but also being willing to solve by eliminating the answer choices that do not work. Okay? Process of elimination is a powerful tool when you're taking standardized testing. So before I talk through the answer to this, scan the answer choices. You have numerical values. You see a few of those show up in the problem. Okay, so let's read what the problem's asking. So you have that linear form. You start with an initial amount of 13.3. The rate of change is negative, meaning that it's being removed from the initial amount. And does that make sense that that would be gasoline in the tank of a car? You start with an initial amount and you remove it. Well, so what does that 13.3 represent in the car? The what? Yeah, that's how much gas is in it to start, right? That's the initial amount of gas. That it holds 13.3 gallons. Have any of you guys had to fill up a car yet? Okay. Does that seem like a reasonable amount of gas that go in a small, probably a really small car, right? But it's reasonable. Like 13 is something that you would see in that. Okay. This is asking you how many gallons of gas are used to drive. So we know that the 13.3 is the initial amount. So we know that we can eliminate that. Okay. How many gallons of gas are used to drive each mile? Well, if we just look at what's left, okay, would any of you guys drive a car that requires 13 gallons to drive 1 mile? No. What about one that requires 221 gallons to drive 1 mile? No. So it's unreasonable to think that any of those are correct answers, which leaves, again, by process of elimination, 0.06. Now, when we look at that 0.06, does it make sense that that might be how many gallons of gas are driven or used for each mile? Yeah, it's our rate of change, right? It's negative 0.06 per m. M represents mile. And so it would make sense to interpret it as the amount of gas that is used per mile. All right, move to the next one down. See if you can answer that question. This one has the 2 variables. See if you can interpret what that would mean and how to use that information to answer the question. All right, so if we look at the equation, we have 310 total training hours. It tells us that X is the number of training courses on site. Y is the number of training courses off site. Okay, so what do you think the 19 and the 34 represent? What does the 19 mean? So the on-site courses, it represents hours, right? It's the hours done on-site. And what would 34 represent? The number of hours done off-site, right? So those are what the parts of the equation represent. And so how many more hours does each online training course take than each on-site one? So the on-site is 19, the online is 34, and so what would the answer be? Just take their difference and you get 15. Perfect. Okay. Good. All right, let's move to the next. Try this problem on the upper right of the second column. If you scan your answer choices before you read through the problem, you see you have a linear form. And it is that y equals mx plus b. So you have rate of change. Your rate of change is either 17 or 9. And then your initial amount is either 9, 17, negative 9, or negative 17. So like just looking at the problem itself, you know which of those you would need to identify based on that. So when you read it, you have a hill that's 17 feet above the ground. So that's an initial height. So what do you expect your initial height to be, or your initial value? Positive 17. Do you need to go any further? Are there any other options that have a plus 17 as that initial amount? No. So there's your answer. You don't even need to go any further. But if we did go further, does it make sense that the rate of change is 9 feet per second? Is that what we were looking at in this equation? Yeah. So it fits both the slope and the y-intercept, but we only needed one because everything was different, or the y-intercepts were all different. All right, let's do this final example here. See if you can answer that, and then I'll give you a little bit of time to work. All right, so we scan the answer choices. We see we're dealing with a function that either has a rate of change of 958, a rate of change of 9, a rate of change of 0.58, or a rate of change of 58. And we see that we have a constant or an initial amount of 0, 0.58, 9, or 9. Okay? So when we look now at the question, we have a monthly fee of 9 plus a per hour fee of 58 cents. So when we look at that, the rate of change is what's different in all of these options, right? There's like the last two have the same initial amount. So because of the rate of change is different for each one, that's what I'm going to focus on first, because once I find it, I have my answer. I don't even need to know what the initial amount is. But if I see that 0.58 per hour, that's my rate of change. So if I go through these and I look to see which of my equations have the 0.58 as the rate of change, the multiplier or coefficient of x, this is the only one that does. And so that is my solution. I don't need to go any further. But if I did, again, I would confirm, does it have a monthly fee or initial amount of $9? Yeah. So it confirms that as well, but that's sort of the process to use going through these.